don't hear that enough.
Okay.
That's the second person I've heard it from.
I love graphing.
I know, it's a wonderful thing. When I was thinking about what last project I had you guys do, that one rose to the top. I'm like, you know,
See, they didn't label.
you guys are going to need to use Excel, most likely in your lives. So here's a quick intro. How many of you had to go online to find other examples of how to do stuff? Anybody have to do that? Before you Tori Claire's speak.
Oh, no, I had them.
Oh, okay.
It was one, I put it for a vehicle.
Good. I mean, that's why I put. Did anybody watch the scatter plot video
There was 50 different.
that I put up? Yeah, good. I like those. I like having it written down and also having a video link because it hits people that learn different ways. That scatter plot video was the one the dude from France actually found. And he sent me a thank you in French for that video. It's adorable.
Because that one before.
I had to ask him to translate it because I'm ugly American though. Yes?
The only thing I found difficult was your directions, because I have Windows 8, and so it's a lot different than your directions.
And Chelsea, you bring up a good point. Now, guys, I want you to hear this, not for this class, because this class is essentially over, but I want you to hear it for your future classes. On the first day of class, and I know this is going to sound like a freaking contract, but it says everything technology in this class is based on Excel 2007. I swear to God, and Microsoft, I hope you're watching this, I swear to God, Microsoft only creates updates to drain more money out of a society they know will buy them. Because the updates, Windows XP was the most perfect operating system Windows ever came up with. And they've now changed it twice since then.
I hate Windows 8. I hate it so much.
XP was bulletproof. So of course they had to change it because they have to give you something that breaks so they can sell you another update. So the thing is, that's where Google comes in handy. I had a couple emails from students in 244 that had to make scatter plots. I can't find the layout tab. So I took a screenshot of me Googling layout tab in Windows 2010 with the solution. I said, here's what I Googled, you go Google it yourself too. That's where I almost like it when that happens because it forces you to utilize that other part of your education that you might not have to use otherwise.
What I do is I just kind of poke around until I find what I'm looking for. Guess
how I learned Excel? That is how I learned. I learned Excel that way. I open a spreadsheet and go, file, click. What's under here? Save. I mean, honestly, it's like evolution, like evolutionarily slowly. But it's how you learn, and you learn it really well because in solving problems, you learn things better. I've discovered, rather than just me telling you a solution, when you solve the problem, you learn it better. So I apologize for the frustration, but at the same time, it's pretty valuable to suffer through that.
I don't know if anyone else heard, but Microsoft is now giving free Microsoft to all students, and I just paid for it last term. But
oh! There is a cloud-based, I think the time is, I think...
No, they've got, actually, you can go to you can go up to IM and get Microsoft Office 2013 on your computer, your laptop, or even on a download for their home computer. But you get 5 licenses with it. You can put it on 5 different devices. And it's the full, yeah, it's free, and it's the full blown out, version. It's called Student, but it's a Microsoft Office Professional, which goes for about $700.
But it's only while you're a student here. When you cease being a student, CSC said they pull it back from you.
No, it's not exchange. Your license is good as long as...
They will not give you something for free and when you're a student and then let you keep it when you're not a student. I already have. That's why I'm telling you this. Now, I'm not saying you shouldn't do it. You should do this because it's free. But realize that once you leave, you're going to lose it. But that's okay. Use it while you're here. Your next school is going to have the same setup. Your next school is going to have the same setup. I mean, that's unfortunate because the way it works, it's basically a cloud-based idea where you get to pull from this. It's not exchange. You're right by saying that. I'm 100% correct. Only because I just heard about this last week and I had to go ask myself. I'm like, this sounds too good to be true. And it was a little too good to be true, but only a little bit too good to be true. Not a lot too good to be true. You still get it for free. You still have access to the entire suite, and I encourage you to use it. But just realize it's only while you're a student at COCC. That's okay, because whatever school you go to next is going to have the exact same deal, and it's no major inconvenience to re-download or reconnect. I don't think it's a download as much as it's a connect. I could be wrong about that. I could very well be wrong about that.
You have to download it from the website.
You have to pull it down. You have to pull down whatever that program is. Yeah, it's some kind of a licensing agreement with you being a student. So I didn't know about the 5 site licenses. That's freaking rad.
I'm going to put it on my laptop, my desktop.
Well, hell yeah, you are. That's fantastic. I mean, I didn't realize that's almost Microsoft shooting themselves in the foot by letting you do that. So by all means, do
Well,
it.
I pay $100 for my 365, and me and my cousin both go towards it because it lets you have buys on it, so.
Perfect, each pay 50
I
bucks.
paid 99.
I don't know, ask the IT department, or ask the, not the IT department, ask the folks at the
I
computer
paid
lab.
like.
Yeah, ask somebody at the computer lab, they'll be able to secure you the right way.
So Sean, the question I had about the project.
Yes.
I had a problem with the Subaru miles per gallon.
Yes,
So, and we were out there and we like, half of us had it one way. and
grab me a
half
break,
had
we'll
it-
take a look. I'll pull the data sheet up, we'll take a look at it at a break.
Oh,
Happily,
okay.
happily. I don't wanna get too bogged down in nuts and bolts, because I wanna keep this craps thing rolling.
Oh, yeah.
No pun intended, that's a joke, actually, that's totally unintended, actually. I'm inbred with bad jokes, that's good, that's good. So, I wanna get back, I wanna finish this craps quiz, because this is all I got left to do for today. I don't think this day is gonna be much longer than the first half. But I wanted to get through this. Jeremiah raised a very, very good question on Monday, and I remember Jeremiah and Michael, I think both, because you guys work in the same group, I believe, on Monday, or at least near each other. You both looked at me, and I remember seeing your guys' faces and remembering your question an hour after class, and then realizing there's got to be something wrong with the way I'm got this quiz lined up. And here's the deal. So everybody, I'm assuming you guys got all the way through the first page. We can put that aside. And you got as far as, I think you're now on the back of the second page, where you kept track of your wins and losses, yes? You kept track of your wins and losses. Okay, so that's the data I want to collect today. That's the data I want to collect today. Now, the calculation that becomes interesting. Oh yes, he is. So if you weren't here on Monday, don't worry about it. Just let this go. Let this go. The calculation that's interesting is when you do, this is a pass line bet, right? We're doing the pass line bet, not the don't pass bet. The don't pass bet's on your exam for next week. Which, by the way, we're meeting on Wednesday, 10. Okay, 10, whatever time it is. 10 o'clock? Beautiful. So the pass line bet, you either win or lose. The pass line bet, you either win or you lose. So you can ignore some of what I've written on the back here. We're going to recollect the data a different way. You either win or you lose. Now, what happens when you lose? Right, you bet your dollar, well you bet Starbursts, but usually it's money. So you bet $1 and you lose that dollar. So you lose, so we're going to put payout here. We're going to put payout here. So you lose your dollar. What happens when you win? Well, what happened yesterday when you won? Monday. Do you remember? You won your Starburst back. So, and this is where Jeremiah's face kind of fell. He's like, and you remember what you said now?
I think a bit more than just like,
Essentially, I gave you 10 Starbursts, yes?
Yeah.
You will never leave with more than 10. So Jeremiah's question was, why do you have extras in the bag? And the quick and easy answer was, I had to buy more the night before and I brought them all down. But the question that got me thinking was, holy crap, if craps actually works like that, you'll never actually profit anything on it. So technically speaking, this is the distribution you guys were playing with yesterday. And I went back to check my source, and my source even had it wrong online. They said the payout for a craps win is 1-to-1. 1-to-1, meaning you bet one, you get one back when you win. Well, it's not technically 1-to-1, it's 2-to-1. You'll get $2 back. That's the gambler's rule. And if you bet $1 and you win, they're going to pay you 2-to-1 odds. But let's just keep it. Let's keep it this, and then readjust the distribution to make this a 1 later. Let's get the numbers first. Let's get the numbers first, and then come back. I want to see what happened to us in the game. Okay? So, what's the probability of winning and losing this game? Because that's what we have to know now, right? That's what we have to know now. We have to know what probabilities go here to figure out, on average, what's going to happen to us. Does that make sense? Hopefully that makes sense. So how often do we win versus how often do we lose? So what we have to do right now, who's here today that was able to do the die rolls last time? This will give us, and you each played 10 times, right? Let me get a quick count. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm going to count again. Keep them up. I want to make sure I count this right, because the thing about craps is these are so close. I got to make sure I count this right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 17. Okay, I was the count. Keep them up. I just got 2 different numbers. Damn it.
You're asking if we played all 10.
Right. So
Played all 10.
but you weren't here. Monday. Did you roll dice on Monday?
No.
They put your hand down. Damn it, it's hard enough to count without it data. Did you do it too, Thurby? Jesus. You know I can't count. Now you're just messing with me.
See, look.
16. Okay, I got 3 different numbers. Put your hands up again. Whatever number I get this time, I'm using.
Go by road.
18. Jesus, I got 4 different numbers. Stand up if you were here and rolled dice on Monday. Trey, sit down. I just counted 4 times. You got 4 different numbers. How is that possible?
Everyone count themselves.
Count by road. That's a good idea.
It's not. Stop talking! I can't tell you to talk! 19. That's 5 different numbers.
There's 18.
18! What the hell?
Count themselves and sit down.
19. Let's do Frankie's idea. Everybody count 1 by 1 and sit down. Let's go by row.
There's 8.
1,
There's 8.
2,
3, 4, 5, 6,
7,
9.
10,
11,
12.
13, 14,
15.
16, 17.
18, 19. 19 was the last number I got. How did I go from, I went from 16 to 17 to 18 to 19. I think I got a 15 there too.
Yeah, you're the 15 also.
16 or 19.
Oh my God. And I wouldn't even care. Honestly, I had never cared before, as we've seen. But the problem is, these are so freaking close that I kind of have to be accurate. My God, 5 different numbers. They're going to take away my math degrees. I know they are. They're going to take away my kindergarten diplomas, what they're going to take away. Math degree. Take away your kindergarten first grade diploma. Okay, so 19 trials. That means we have 190 games we played, yes? Because you each played 10 games, correct? You each played 10 games. So we know that these probabilities, these are the empirical ones. The empirical ones are going to be out of 190 each. Let's put them on this side before I get guessing when we're done. So let's see. Let's see how we did. Shoot. I gotta count again.
Oh, great.
Yeah, I know. Screwed. So I think we may have to. Let me get some technology to help me too. Actually, I'm going to walk to each of you. Raise hands with the number of times you won out of your 10. Because each of you rolled 10 times, right?
Yeah.
And each of you also won some of those 10 times. So raise your hands and show me the number of times that you won out of your 10. And I'm just going to walk to each of you up and down the rows, and hopefully I can... Right.
And nobody move.
Nobody move or talk, including me.
5.
You making that up?
No.
Okay. Yeah, I got a calculator. I'm not taking chances this time.
The last class.
Stop talking. 11D12. That's like a Seuss number.
They love those numbers.
All right. Syntax. No. I put an extra plus sign at the end. Sorry. 93 wins. I'm not counting it again. I don't care. I don't care anymore. 93 wins.
So 97.
So therefore, we have to have 97 losses. Yes. I told you it's going to be close because craps is a genius game, and you're about to find out just how genius it is. So here is this is called a probability distribution for craps. Now it's not quite correct because thank you Jeremiah for bringing that point up yesterday. I can't thank you enough for that one. That's a good point. We're going to address that momentarily. You want more Starburst? Oh.
That's why I asked the question.
Oh.
I was
I
like,
didn't bring more.
how do
I'm
I get-
sorry.
how do I get
I'll have them at the office if you want to come back.
That's what I did on Monday.
Oh, Monday, you wanted more
Yeah.
Starbursts.
It's like, I don't
Because technically speaking, you should be able to increase the number of Starbursts that you had above the 10. But if you go in with 10 and you bet one and you win, you should now have 11. You shouldn't have 10 back. So we'll adjust that momentarily. We'll play Vegas, if you will. So if I asked you, what we're going to do right now is we're going to skip part 2. So I'm going to give you guys those 2 points. Don't worry about that. The how do we do on class as an average? We're gonna answer this one using this distribution. Because what I want to know is, what did we win on average? And I put win in quotes because we actually lost on average, didn't we? We broke even 93 times out of 190, and we lost $1 97 times out of 190, which means pretty clearly we're down money. Even with the wrong distribution, we'll fix the distribution momentarily, and you'll see how genius Vegas is. So if I had to average this distribution, how would you do it? If you had to find if I want to know my average payout, so we're going to put average payout. Average payout with, I'm going to put this quote unquote wrong, with the wrong win amount. So we're going to use this 0, even though that 0 is technically wrong, because the Wikipedia page I pulled it off had the wrong damn note on it. That's okay, we'll deal with that. I should know better to trust Wikipedia blindly. How do we do it? I've actually found errors in there before and posted them, and this one I just assumed this one was correct.
You just divide the 93 by 190?
Well, that's the probability. What does that come out to be, Michael?
That comes out to
49%?
49%.
49%, so that's 0.49, and this is 0.51. So that tells me the chance of winning and the chance of losing on any given one. But what I want to know is I want to see those chances applied to, oh, speaking of which, what does 49% probability mean again? What does it mean when you have 49% probability? 49% of the time on average, you're going to win. Does that mean out of every 100 you're going to win 49 times? But it does mean you're going to win 49 times on average, especially over time if you play long enough. Which means out of 100 times, you're going to lose twice more than you win out of every 100 trials. Is that fair? Is that line of, okay, good.
2 more.
Oh, 2 more, let's say 1, right, 2 out of 100, twice out of 100.
You said twice.
Twice out of 100, right, 2 more times, twice out of 100. You're going to lose twice more than you win. Oh, not twice, 2 times more.
Yeah.
2 extra games more.
Yeah.
So, in order to calculate on average how much you win or lose, you have to do a weighted average calculation. This is the GPA quiz. If you chose to do that GPA quiz for today, which I don't think a whole lot of you did, that's okay. When you have a distribution like this, you can find the average pretty easily by multiplying this times this, and then adding it to this multiplied by this. It's a weighted average. We've done them a couple times now in class. We do them quite a bit, actually, especially this back half. So you take the 0 times the probability of getting that 0, which is the 0.49, plus the -1 times the probability of getting that -1, which is 0.51. Now, technically speaking, we've had this discussion before. Let's have it again, because I think it's that important. You then have to divide, because it's an average, you'd have to divide by the sum total of your data points, which would be the sum total of this row. But what does this sum up to?
Or 1.
1, which is 100%, right? So you could divide by 1, but it's kind of pointless to. That's the average right there. There's no need to divide by anything, because the division's already happened right here by the divided by 190. You already took care of it. That's why we like this tool. So on average, how much do we win? Well, that zeroes out. You lose 51 cents. Because remember, this is dollars, that's dollars, and that's a probability. So on average, you lose 51 cents per game. On average, you lose 51 cents per game. Does that make sense from a Vegas point of view? It has to, doesn't it? Now, Rob, what are you thinking right now? Tell me, brother.
I wasn't paying attention earlier. I was trying to figure it out.
Oh! What were you trying to figure out? Tell me what you were trying to figure out.
Where you got 49 and 51.
Oh, brother. 93 divided by 190 is about 49%,
Okay.
0.49. That's all that is. Just a decimal is easier to deal with than a fraction, I think.
Okay.
Thank Mike for that one. That was good. Now, what Jeremiah and inadvertently Mike, because you looked at me right after Jeremiah said it, was this isn't exactly right when you're playing craps. This is why I had to change the quiz, but you already had the quiz. This is not exactly right. You don't just simply win back your ante when you play craps and you win a past line bet. They actually pay you 2-to-1 odds. And odds is used to it's a 2-to-1 payout. So if you bet $1 and then you win on that roll, whether it's a point or a come out roll, whatever it is, they give you $2 back. Now, one of those dollars, you're not really, you're covering your ante with one of those dollars, but the other dollar is pure profit now, isn't it? Now, I want you to think back. We've had this discussion informally before with the Gambler's Ruin. If you play craps and you really want to win $1, you bet $1 and you play. And if you win, they give you 2, which means you've profited $1. But if you lose, you then bet 2 extra dollars. If you win then, you win back 4 2-to-1 payouts. But that guarantees, so that's what we have to adjust right now. But here's where Vegas is genius. Even if you make that a 1, even if you make that a 1, let's make it blue so it stands out, or green. So this is the right way, the average payout with the right amount. If you make that a positive 1, yes? We can now do the average payout with the correct. With the what happens to the 0? It becomes a 1, which means on average, what's happening? You're still losing, but you're only losing 2 cents per game on average, which means if these probabilities are correct, they're almost correct, they're damn close. Vegas can guarantee every person that walks up to the craps table and hands $1 over is not really gambling. They're simply coming up and depositing 2 pennies into some urn. That's essentially what's going on. That's what that means. This means on time, or overtime on average, you're going to lose 2 cents for every game. Now, is it actually possible to lose 2 cents on any one game? No, you either lose $1 or you gain $1. That's the.
So you walk away, you win.
You walk.
Playing.
If you walk away, you win. If you've won right before that.
Yeah.
But that's the kick. That's the catch. How many times in Vegas or on the game Deal or No Deal? Keep playing. You've stuck it out this far. Keep going. Good Lord, no. The more you go, the more you lose. With every game you play, you lose 2 more pennies. Now that doesn't seem like much, does it? And that's not a whole lot, is it? But how many games of craps are played in Vegas? Right? Think about those tables. How many people are around one of those tables? And how many of them are betting on that? It's not just the person rolling the dice. People around the table are also betting, aren't they? That's what gets interesting. That's what gets interesting with craps. Screaming and bringing them in and bringing them in. And this is so small that it's appealing. Now, if you look at the first page of that quiz, that's a craps table. And there are a bazillion different ways to bet. You can bet on For the Hard Way, you can bet on box cars, you can bet on snake eyes, you can bet on snake eyes, there's a snake eyes bet. Which means they're going to pay you more when you win. They're going to pay you more when you win, but you don't win as often. So it balances, you see, so it balances. Every average for every bet in Vegas is negative. Just know that. So when you go there and you lose your money, you're happy. Because you can't be pissed. Because you know going in you're going to lose your money on average. Frankie said the only way to win is to walk away while you're ahead. The problem is you don't ever know when you're going to be ahead. See, that's the problem. That's the problem. Does that make sense? So, thank you, Jeremiah, for saying that. Otherwise, I never would even thought to explore it any further. But, Chelsea, go.
Well, for our question that we're answering.
Oh, yeah, let's adjust that, too. So, for that number 3, how do we do on a class on average? Lost 2 cents on average per game.
So you want us to use
Yeah, let's use the correct one. Let's use the correct. Just put in words. I understand that I screwed this quiz up by having the odds wrong. So just put somewhere on there, we lost 2 cents on average, and I'm a happy guy. The big thing is making sure we can calculate this average based off of a distribution, which I think we know. Now we've seen it a couple times, I think we can see it. Now it says, 2 points, we'll do this together, comma 200. I have no idea what that number 200 is there. Obviously I tried to count, making the quiz. And I got up to 190, and I had to get a little bit further. Okay, now these last 2, yes, these last 2 we can answer together. We already have one of the answers. Oh, yes. Number 4, what is the probability of winning on a pass line bet? The experimental probability of winning on a pass line bet. Trey is looking at it. What is the probability of winning on a pass line bet? We already figured it out. It's 49%. You win 49% when you bet this way. Experimental. Experimental. That's the experiment. That's based on our 100. How many trials do we have? 190, 190, 150, 160, whatever the hell it was. 49% of the time, we won. If I made you guys play 190 times again, would you guys win 93 out of 190 times again? Do you think? Do you think?
No.
Trey?
It's almost the exact same, even when you do it 16,000 times on your exam. It comes up the exact same way.
Good. Hold that thought. That's what I wanted to finish the day with that thought. Thank you, sir. Thank you, thank you, thank you. So, what was the, I'm sorry, what was the answer? Would we get 93 out of 190 again? What do you think we get? Ish. Oh, around 93 out of 190. Maybe 92? 91? 90? 85? 80? Ooh, now we're starting to, oh, gut's saying, that's too low. Okay, 190, how about 100 out of 190? Maybe, oh good, that's good. We're getting the 110 out of 190? 120? Now we're getting way too high, right? Vegas would never allow that. 120 out of 190 is what, 1.3 if we multiplied it out? And that would be giving us too much money from Vegas. So Vegas has to know. Vegas has to know how likely it is to win on this bet. So they know what to set their payout to, don't they? Guess what they don't do? They don't do it this way. They don't give a bunch of, they don't open a casino and go, okay, time to set the payouts, here's a bunch of dice, everybody come in, here's a bunch of money. No, they don't do that. What they do is they figure out ahead of time what this chance is. That's what we're going to do right now. We're going to answer that last question on your quiz. Our last 2 points together in class. I'm very sad right now. So, let's analyze the theoretical probability of winning on a pass line bet. And thank you, Trey, for bringing up the exam, because that's the don't pass bet. That's when you're betting against the roller. Super fun. Super.